Okay, so I just wanted to show you a little bit of the magic using some homework problems that you were not assigned to. So it's not assigned to do. So I'm going to start with number 42. So 2 to the x plus 1 equals 5 to the 1 minus 2x. The goal is to get all the x's onto one side and then just have one x. And then we can convert to log form. So I'm going to write this like 2 to the x times 2 to the first because I'm using that exponent property that when I multiply things that have the same base, I can add their exponents. So I'm just using it going backwards. And then same with on the right side, I am using the property that when I divide things with exponents, I can subtract exponents. And again, I'm using that also backwards. So this is 5 to the first over 5 to the 2x. Now I realize that I have an x here and here. So I want to get those onto the same side. I also, whenever I have a fraction, I just try to multiply by the denominator to get rid of the fraction. So I have that. So now I have 5 to the 2x times 2 to the x times 2 equals 5. Well, I do want to get my terms with x's alone, so I'm going to divide by 2, and I'm going to have a fraction, and that is okay. So then I will have 5 to the 2x times 2 to the x equals 5 over 2. Now I'm going to remember another exponent rule that says that a to the m raised to the n, I would just multiply those, which means I can go backwards and I can kind of do this. So that means I have 25 to the x times, oh, I'm sorry. This is supposed to be 2 raised to the x, not 2x. Sorry about that. So 25 to the x times 2 to the x equals 5 over 2. And then again, I can use another rule that when I have a times b to the m, that's a to the m times b to the m. So I'm going to go again backwards with that I have 25 times 2, both raised to the x, equals 5 over 2. So finally, then I have 50 raised to the x equals 5 over 2. And now I can put that into log form. So log base 50 of 5 over 2 equals x. And that is my final answer. And then if I want to have it be the approximate, or if I want to get the decimal answer, I can just put that into Desmos or another calculator. So you can see that I used a lot of exponent rules here. The other one I was going to show you is number 44. So I'm going to go ahead and clone this page and delete. I'll keep my exponent rules, but I'll delete some of the work here. Start a new problem. So number 44 looks like 4/3 to the 1 minus x equals 5 to the x. So I can say 4 to the 1 minus x over 3 to the 1 minus x equals 5 to the x. And then I'll multiply both sides times 3 to the 1 minus x. And get rid of those. So then I have 4 to the 1 minus x equals 5 to the x times 3 to the 1 minus x. Okay, so then I have 4 to the first over 4 to the x equals 5 to the x times 3 to the first over 3 to the x. So now I just want to get this guy, the 4 to the x, over here. And then I want to get this 3 to the first to go away. So I'll just put it down here. So now I have a little bit left over from my last problem. So now I have 4 over 3 equals 5 to the x times 4 to the x over 3 to the x. Now you could have skipped that, writing that step, and just written 5 times 4 over 3 to the x. So 4 over 3 equals 20 over 3 raised to the x. No, I cannot multiply by 3 on both sides because I have that raised to the x part. So I'm just going to have to use logs. So log base 20 over 3 of 4/3 is x.